health, psychology, and human nature with André Sturesson. Hello, friends. Do you know what would be one of the best things that could happen in the entire world? That would be if you would follow me on Instagram or Facebook. That would make angels sing, lonely kittens find a new home, and dinosaurs to come back. So please follow me on health, psychology, and human nature on Instagram or Facebook. Hello there, friends, and welcome to another episode. Have you ever wondered why we do what we do? That is something that I think about a lot, like why we crave unhealthy food, why we want to tend for our young, for example. And in today's interesting episode, me and Katja Valli, an adjunct professor, will talk about what evolutionary psychology is. So evolutionary psychology has a lot to do with these why questions, why we tend for our young, why we like tasty food, why we don't always want to go out for a run. And we also talked about other subjects, other related subjects, such as evolution, psychology, the mind, behavior, and much more. A very interesting episode with Katja Valli. And Katja, she's an adjunct professor at the University of Turku in Finland, and she has an interest in consciousness, altered states of consciousness, sleep, dreaming, anesthesia, and evolutionary psychology. So, without further ado, please enjoy. So, Katja, welcome to the show.
Thank you very much.
I'm very glad to have you here. So, big thank you for taking the time to talk about this fascinating subject.
You're welcome.
All right. So, today we're going to be discussing evolutionary psychology. And I thought that we would try to break down this field by starting off talking about some different concepts and some different subjects here. So I would like to start off by just asking you if you could explain what evolution is.
Well, basically, evolution is change in the designs of species over time from generation to generation. So due to genetic modifications in successive generations, the species gradually changes over time.
Right. So it's basically that if a species, if like a breed of cats or something else, if they are successful, then they will reproduce, and if those that are more successful will get or will be more likely to reproduce.
Yeah, what you are describing is one mechanism that evolution works with, which is natural selection. So evolution in itself is just change.
Yeah.
And this change can go any direction, and then there are different forces that drive this change.
Right.
There are random forces, which are not kind of guided by any selective processes, but the most powerful modulator of this change is natural selection, which basically means that those individuals who are well adapted to their own environment are more likely to survive and more likely to leave offspring than the individuals who are, less equipped to handle the challenges in the environment. So it is therefore the genes of those successful individuals that go to the next generation.
Right, and one thing that I think is quite important here is that it's not necessarily the strongest or perhaps the smartest that gets to reproduce. It's the one that is most adapted to its environment, right?
Yeah, and what then does most adapted mean? It depends on the environment. So the individual's physical and social environment.
Yeah.
What is most fit. And of course, because there are these random forces, even the individuals that would be the smartest or the strongest, if they happen to die accidentally without leaving any offspring, this means that the unique genes that or gene variants that they might be carrying disappear.
Right.
So evolution is all about reproduction.
And it can also be, right, because I remember these fishes there was these fishes that were living down in a, like, I don't know if it was a dark cave or something, or just some place where they didn't get any light. And you would think that it would always be good, for example, to have eyes. But eyes are also quite costly. I mean, it costs to produce eyes. So these fishes then started to change to remove these things that have been developed over a long period of time, because it's not needed in that particular environment.
Yeah, exactly. That is how natural selection can work. So adaptations that are not useful in a new environment can gradually start to get weeded out. So like the cavefish that you talked about, it has many different populations, some of which live on reefs, and their eyes have been maintained. But then this one particular population that started to live in caves, gradually over hundreds and thousands of years, they basically lost their eyes.
Yeah. And it's also, it's also, if you look at hominid species or some another species that was quite similar to us, like the Neanderthals, I mean, they were thought to be stronger than we were, but still, it was our species that did survive in the end. So it's not necessarily the strongest one, or it's the one that's most adapted to its environment.
Yeah, and we don't actually even know why Neanderthals became extinct. So what was the selective advantage that modern humans had? Because this didn't only happen with the Neanderthals. There have been many different human species existing at the same time as our species.
Yeah.
But when our species has migrated to the areas inhabited by these other humans, they have gradually all become extinct.
Yeah.
So that we are now the only living human species.
And that is also, I think, a quite fascinating idea, that there's actually been so many different species. And I remember reading about this for the first time, these species that I think it's Homo florensis. I'm not sure. Homo florensis, are those the ones that are quite short?
Yeah, they lived on an island. And a typical adaptation over time to conditions where you have very limited resources is that the organisms become smaller. So these were like pygmy humans.
Exactly. Yeah, that I think was quite fascinating, because at least me, before I really understood that there's been so many different species, it's a quite strange thought almost, because you used to seeing other humans quite like yourself. So it would be quite interesting to see somebody who is pretty much like yourself, but still varies a bit.
Yeah, and we still do not know why exactly all these other human species have disappeared. That why is it that modern humans were so successful in harvesting resources from the environment that they seem to have, if not on purpose, but at least accidentally driven other human species to extinction.
Yeah.
And also other large mammals have disappeared when modern humans have migrated into new areas.
Yeah. All right. So that's a bit. So evolution is change over time, and then we talked about natural selection, which pretty much means that those that are better adapted to their environment, they get to reproduce, and they survive and reproduce. So that's a bit about the one part of the evolutionary psychology, and then another, of course, important part is psychology. So what would you say, if you would explain psychology, what would you say that psychology is?
Well, basically psychology is a science that studies the human mind and behavior.
Yeah.
So that would, I think, be the short description of what psychology is.
Right. And for those that are not quite familiar with the concept, the mind, what does the mind mean, and what is it?
Well, for me, how I would define mind it is the subjective experiences that we have. So I would define mind in the same way as consciousness is defined. But of course, in the mind, there are also many non-conscious processes that we can never gain access to. For example, how we process visual stimuli from the environment and how the brain creates an image of it. That is also kind of part of the mind, but it's the non-conscious part. Right. But all those computations in our mind that are there to produce behaviors.
Right. So what does it mean? All the computations. What does that mean?
So all the processes that our brain conducts, whether they are conscious or non-conscious, participate in producing behavior.
Right. So that is what I find quite interesting. So it's both the unconscious parts and it is like the more conscious parts. So like if we could talk about that just for a second, so because that is something that I don't think everybody fully understands. So now we get into another concept, which is consciousness. So like what is consciousness? If you would explain that.
Yeah. So for me, consciousness is simply defined as the ability to have experiences. So if an organism has any types of experiences, it feels, it perceives, it thinks, it feels like something to be this organism, then the organism is considered to have consciousness.
Right. And I think for me, or when I tried to understand this from the beginning, I thought, of course, we are also having conscious experience when we are dreaming, for example. But still, I think when waking up, I think that's a quite good distinction, at least for a change in consciousness. Because when we wake up, we start to see things, we start to feel things. And those are kind of experiences that are part of consciousness. So it's pretty much, or I see it as pretty much as everything that we feel and see when we see something, when we see a color red, or when we are talking to each other, we hear the sounds. Well, I mean, it's pretty much the experience that we're having that to me is consciousness, or big part of it.
Yeah, and there are different kind of descriptive levels of consciousness. The very basic would be phenomenal consciousness, which is the having of experiences.
Yeah.
And another layer that is built on top of that is reflective consciousness, which is the ability to think about your own experiences, to make judgments and evaluations of your own experiences. And also you referred to dreaming.
Yeah.
It is possible that our consciousness is disconnected from environmental stimuli, as it is when we are dreaming. And when our consciousness is then connected to the environment, when we are aware of what happens in the environment we see and can interact with our environment, that can be called kind of connected consciousness. So right. You are connected to the environment.
Exactly, because we can so to speak have an experience of seeing even if our eyes are closed. For example, when we're dreaming, we're not taking in the environment around us. We're not taking in the things that we are seeing in the dream. We're experiencing the dream even if our eyes are closed, so to speak.
Yes.
And I think that's a very good example of understanding that it's not the eyes that actually creates what we see. They're a part of the process, but we're not see with eyes. It's the brain.
We see with the brain.
Exactly, we see with the brain, which is counterintuitive, I think, for people who haven't studied this or haven't heard about this before. Okay, so consciousness is like the experience part of the mind, and then it's also this non-conscious part. Could we talk a little bit more about that as well? So what are all these like non-conscious things?
Well, for example, how our eyes receive electromagnetic signals, how they are transported from the retina through visual pathways to our occipital cortex, where the brain processes visual information, and how this information is integrated with our other senses so that we have this unified picture of the world. all those processes are non-conscious in the sense that we can never have access to experiencing how our brain creates a visual experience, for example.
Exactly. We more experience the end product.
Exactly.
Yeah. And that's quite fascinating as well, because we have all these processes going on all the time. I mean, even if we're not aware of them.
Yeah, and the brain never sleeps.
Yeah.
It processes information all the time.
Yeah. But from you, I mean, you've been studying consciousness and studying, and you know a lot more about the brain than I do. What would you say, like, how much of the brain's, how much of what we, or how much is more of the conscious experience or the conscious part of the mind, and how much is more of the unconscious part?
Oh, I think that is a question that we really don't have an answer for, given that consciousness cannot arise without these non-conscious processes. So it's, I think the question is, the question itself actually might be misguided, because I don't think that we can tease these two phenomena apart.
Yeah. They're tied together.
Yeah, they are tied together.
Yeah. Well, one thing that I also been thinking about when I was thinking about the mind, about the conscious and the unconscious part, is also that there's a lot of things going on all the time. So, for example, me right now I'm mostly experiencing our conversation. I mean, listen to you when you're speaking, and also thinking about the things that we're talking about. But at the same time, there's also a lot of stuff going on that I'm not conscious about. For example, I mean, there's people walking by outside my window that I'm not conscious about, but that I probably are taking in some information about. And also about my feet, for example, touching the floor. There's this sensory input that is coming in all the time that I'm not conscious about, but are still being processed as well. So I think that's also another good example of things that are being processed but that we're not experiencing.
Yeah, and these are basically, there has been the question of whether these really are conscious experiences, but consciousness has kind of like a center stage, which is our attention, so what we pay attention to. And typically there are a lot of things that we can have access to, but we don't actively do so because the spotlight of our attention is quite narrow. And now if you start paying attention to your feet, you realize that yes, your feet have been there all the time.
Yeah.
And you have
Yeah.
you have had a sensation about your feet, but it is almost as if though they have not been there because you have not been focusing on them. So we have a lot of material in our phenomenal consciousness all the time, but we can only pay attention to a small part of that. So I am now focusing mostly on our discussion, but I see a little bit of movement on the corner of my eye, and there's a bird flying.
Yeah. Yeah.
I can see through the window, and the branches of the trees are kind of moving. But just 2 seconds ago, I wasn't paying any attention to the scenery outside.
Exactly.
But it's still there, and I can see it from the corner of my eye. But it's almost as if though it isn't there until I pay attention to it.
Exactly. Is this a refrigerator thing almost? Like is
the light on or is the light off?
Exactly. Yeah. Okay, so when we're talking about the mind, so that's basically that our brain is processing like a lot of information and the end processes or the end product kind of is what we experience, but also not it's also not what we experience. There's also a lot of things that never reach our consciousness as well, right?
And these might actually be, evolutionarily speaking, quite adaptive.
Yeah.
So instead of taking in all the possible information that is out there in the world, our attention makes us focus on the aspects that are most important, so that we don't overload the brain, so to say. We only pay attention to those things that are most crucial.
Exactly. It's only the most crucial part that ends up in our consciousness.
Yeah.
Yeah. Okay, I think we got a better grasp about the mind. So it's the brain processing a lot of information. It ends up in our as these experiences, but also as things that we don't experience. And so, what about behavior and the other part of psychology? What would you say behavior is?
Oh, behavior might be tricky to define. Usually, we think of behavior as anything that can be observed from the outside. So the person is actively doing something that can be observed, like moving a hand. But then again, the question is thinking behavior.
Right.
So are there other behaviors that only occur inside the brain and are not observable in any way? So I think this is a definitional question of how do you want to define behavior?
Right. Yeah. Okay, so but we can all agree that the things we do, if we yell at somebody, if we open a door, if we do something else,
those definitely can be defined as behavior.
Exactly. Those are behaviors, and then these more cognitive processes that we can't see from the outside. Then that's more of a discussion if those are behaviors or not.
Yeah, yeah,
right.
And I think defining them as cognitive processes that can or that may or may not lead to behaviors is a kind of a good definition, so that we could reserve the definition for behavior only to those things that are somehow observable.
Right. Okay, so if we go back then to what evolutionary psychology is, what would you, now we're talking about evolution, and when we talk about psychology, so we got to these other subjects and learned about those. What would you say that evolutionary psychology is?
Evolutionary psychology is a branch of psychology that focuses on so-called ultimate questions. So what is being investigated in traditional psychology? It is basically how our bodies and brains produce behavior, and how our genetic makeup, our age, our sex, our lifetime experiences that have modified our brain, how those affect how we behave. So traditional psychology focuses more on the individual and the individual's life history in explaining behavior. And it tries to describe what kind of processes in the brain underlie behavior, for example. So it tries to answer questions such as how behaviors are created. And what evolutionary psychology kind of adds to this is another level of explanation, which we call the ultimate explanation. So it tries to ask questions that, why are these behaviors there in the first place? What is the evolutionary history of these behaviors in this species and in other maybe closely related species? And is it that these behaviors could have served some sort of adaptive function in our ancestors? So if I would take an example, let's say that traditional psychology explores human memory. So it tries to describe how the memory works, what kind of things we remember, what kind of things we easily forget, how much information we can keep in our short-term memory, how short-term memories are transferred into long-term memory, what kind of biochemical and hormonal processes affect this, how individuals' experiences affect what the individual remembers. But then the evolutionary question would be, why is it that our memory functions this way? Why is it that certain things are easier to remember and learn, and other things just kind of disappear from long-term memory? So what is the purpose that memory serves? For example, we know that we much more easily form memory traces of events that we experience as emotionally negative. And it is much more easier to remember all kinds of negative stuff that has ever happened to you than positive experiences. And mundane events are most easily forgotten. So why is it that our memory is highly efficient in remembering negative things, but less efficient in remembering positive or neutral things. And what memory might be, what might be the ultimate function of memory? Could it be that it is not an accurate representation of our past, of what has happened to us and things that we know, but rather it is a tool that helps us to predict the future? So based on our past experiences, when we monitor the environment, we are constantly trying to predict what is going to happen next. And for these future predictions, what is important is the types of memory traces that best alert us to, for example, dangers in the environment or things that might be harmful for us.
Right. Yeah, I think that's a very good example. So why are we remembering, for example, if somebody is yelling at us better than if somebody just walks past us, and the reason why in the end we are remembering those things better.
Yeah, and that is exactly what evolutionary psychology tries to add to psychological explanations, are these ultimate explanations. Why do we have the types of behaviors that humans typically have? And whether these behaviors could be the result of natural selection, or whether they could be adaptations.
Exactly. So if these behaviors helped us to survive in the future, or not in the future, but in the past.
Yes. So anything that was helpful in terms of increasing survival and reproductive success in our ancestors could be a feature that was selected for.
Exactly. There's really a lot of things that can be analyzed from this perspective, and that's where you can get some additional dimension almost of why we have all this.
Yeah, and the explanations that traditional and evolutionary psychology offer, they are not in competition with each other, but rather they ask slightly different questions about the same phenomena. So they provide kind of complementary information about the same thing.
Yeah. So the big difference between normal or traditional psychology is probably a better word, and evolutionary psychology is that evolutionary psychology tries to understand why.
Yeah.
It's more about the why question. So why do we remember these things better? Why do we have such a big prefrontal cortex compared to other species? Why? Yeah. So it's a lot about the why questions.
Exactly. Yes.
Yeah. Which I think is super interesting, trying to understand us, because I really think that understanding us right now also can help us to, because I'm also interested in health and in well-being. I think that understanding us as human beings and why we are the way we are also can give us insight into why certain behaviors or certain foods or other things might be more beneficial for us now than others, for example.
And it might also explain why we tend to like certain things and tend to engage in behaviors that are actually not necessarily good for us in the current environment.
Exactly. And that's for example, everybody loves candy. I was on a birthday party yesterday, and there was a 1.5-year-old there, and we had cake. And it's such a fascinating thing to see a 1.5-year-old eating cake. It's just, it's such a strong stimuli for everybody, of course. But it becomes even more evident, I think, when you look at such a young person.
Yeah, we have a kind of innate preference for sweet and for fatty substances. Also salty things. And basically what sweet and fatty tastes are all about, they indicate that whatever you are eating has a lot of calories. And those ancestors who developed a preference for eating stuff that contained a lot of calories might have been a little better off than those ancestors who tended to love bitter tastes that typically relate to plant material that is low in calories and might have plant toxins. So certain preferences that we have, starting from simple things as taste preferences or dislikes when it comes to taste, might have evolutionary roots that have been useful for our ancestors.
Yeah, it seems. I mean, it seems such a good thing to be looking out for high calorie food. That's one thing that probably helped us to survive better.
But then the problem is when the environment changes, like for our species, it has changed drastically over the last 100 years even. So now that food is abundant in most parts of the world, our innate preferences, basically what they make us do is they make us eat too much.
Yeah, exactly.
Which then again results in obesity and health issues.
Yeah.
But understanding why people eat too much might also hopefully help us tackle the problem.
Exactly. And I think that kind of goes for many of the lifestyle things, like, I mean, exercise, for example. It's not I think that our ancestors went out for a 10-kilometer run just for the sake of it.
No, but they did. Yeah, they did regularly. They had physically very active lifestyles because they had to.
Exactly. Yeah. Because they had to gather food and other resources to be able to survive.
Yes, and our bodies are therefore designed to move and not sit still at an office in front of the computer for 8-9 hours a day.
Yeah, exactly. I mean, it's when you look at the person, I mean, all of these things, if somebody starts, if you're not exercising, if you start to exercise more, and if you don't eat as much of all these high caloric foods all the time, if you don't only eat pizza, and also, I mean, if you sleep during the night with perhaps, I mean, less light and less noise and temperatures that also are a bit lower, and if there's not too high, and all these other things, that, I mean, there's a lot of science, a lot of research that shows that these kinds of natural things that helps us to have better lives also.
Yeah. And for example, we tend to think that insomnia is an illness.
Yeah.
And about 30 to 50% of people complain of sleep problems on a weekly basis.
Yeah.
But it seems that it is our lifestyles that induce most of the symptoms of insomnia. Okay, we do have some individuals who have always slept badly from early childhood on, who basically have like primary type of insomnia. But majority of insomnia symptoms cannot be cured because they are not an illness. They can only be cured by lifestyle changes.
Yeah.
And there was a really interesting study on a hunter-gatherer population about their sleep. So they slept on average 6 to 7 hours a night. They went to bed a couple of hours after the sun went down, or bed, because they didn't have beds. They slept outdoors in family groups, covered in light blankets, and they tended to wake up an hour before the sunrise when it was the coolest time of the day. And when they were asked about insomnia, they couldn't understand the concept.
Yeah.
And when the scientist explained that, do you ever have this feeling that you really want to sleep, but you just cannot? Then there were some individuals who said that, yes, I've had that maybe once in my life.
Yeah.
This study might be a good example of how our Western lifestyle, and even in having massively comfortable beds, can give us symptoms of insomnia that really, from if we would kind of have a more naturalistic environment for our sleep, and we would have a less stressful lifestyle, our sleep quality could significantly improve.
Yeah, I think so. I think whenever you listen to a lot of experts, like I listened to a researcher called Matthew Walker, who written a book called Why We Sleep. It's a fascinating book, and he's also a really good researcher who has been done. I mean, he's always talking about Mother Nature, and I mean, if I mean, sleep is kind of. He says that sleep is kind of the most dangerous thing, lying on the floor, not being able to defend yourself. Somebody can ambush you quite easily. I mean, you probably had somebody, you might have somebody looking out for you. But I mean, if it didn't have a vital important thing for you, then you wouldn't be asleep probably.
Yeah, but I think it was Alan Rechtschaffen who said that if sleep doesn't have a function, then it is the biggest mistake that evolution has made.
Yeah, I think so. And
sleep is pervasive in the animal kingdom. I mean, pretty much all the animals that have been studied sleep, although there's a lot of variation in how different animal species sleep and how some animals can actually undergo long periods of sleep deprivation without having harmful effects. But given how widely spread and how pervasive sleep is in the animal kingdom, it means that it needs to have some very vital functions.
Yeah, for sure. Which also makes it so important that we focus on trying to get the amount of sleep that we need.
Yes, because we know that sleep deprivation does have harmful consequences for our health and for our well-being, also mental well-being.
Yeah. Do you know about studies of do you know what the effects are on well-being from sleep deprivation?
Well, just short-term sleep deprivation, if you think of mental well-being, it increases irritability. So we become more moody when we are tired and sleep deprived. And people who are depressed also much more often complain of insomnia symptoms. Here we cannot be certain which came first, the depression or the insomnia, but it seems that it is a two-way street, that if you first get depressed, that affects your sleep, but also if you suffer from insomnia, it increases your risk to get depressed.
Yeah. I'm also I have done a previous podcast about stress management, and there I was talking to a professor, and he also said that just by curing the sleep problem in people that were depressed, shown to have quite a significant effect. Not on everybody, of course, but on a group level, it seemed to have an effect on how depressed people were if you just was focusing on the sleep.
Yeah, if you can normalize the sleep pattern and get these people to sleep enough.
Yeah.
That alleviates also the depressive symptoms in many.
Yeah, exactly. All right. So evolutionary psychology, what would you say that the difference is between evolutionary psychology and evolutionary biology instead?
Just that the evolutionary psychology focuses more on the human mind and human behavior, while evolutionary biology is kind of like an overarching background field of science that tries to explain how evolution happens, what are the mechanisms of evolution, and so on. So it's like evolutionary psychology piggybacks on evolutionary biology
right.
in trying to explain mind and behavior of humans.
Right. So it's more why our mind is working like the way it does.
Yes.
Okay. So could you give some examples of these kind of these behaviors or things that have helped us as human beings?
So evolutionary psychology can be basically used on any kind of sub-discipline in psychology, whether developmental psychology or understanding emotions or understanding our social behavior or our mating behaviors. So picking an example, well, I might pick an example from our mating preferences, because I mean we tend to think that men and women are very different types of creatures, but when it comes to our psychological faculties, we are extremely alike. And there are actually very few sex differences in our psychological faculties that would have any significant effect sizes. But one thing where men and women are different is our mate selection preferences. In a sense that men tend to pay, when they are thinking of a long-term mate, more attention to physical characteristics such as youth and physical attractiveness, because these are actually signs of the fertility of a woman. And for ancestral males, it paid off in terms of offspring to mate with women who were fertile.
Mm.
And women, on the other hand, can only have a limited number of offspring compared to males. So the potential number of offspring for women is much, much less than it is for males. So what is important for women is to select the kind of a long-term mate that is reliable and helps to take care of the offspring.
Right.
So women pay more attention than men do on things like social status, because that often relates to resources that the man has, income level, ambitiousness and industriousness, because these might signal that the man is kind of striving in life, so is likely to have resources at some point. And physical attractiveness is less important for women. Both sexes, however, when they think of what kind of a long-term mate they would like to have, is that they pay attention to things like dependability, emotional stability, that the person would have similar types of values and beliefs, and so on. But in certain long-term mate preferences, men and women have slightly different emphasis, because the kind of what is beneficial for reproductive success is slightly different in males than it is for females. Females who have to kind of go through 9 months of pregnancy and breastfeeding, this is a huge physiological investment. And engaging in this kind of an investment pays off much better if you have somebody who supports you through the pregnancy and sticks around then to take care of the offspring. While for men, mating with fertile females, possibly having one long-term companion and then maybe saving a little bit of resources to get access to other fertile females, might have been a better reproductive strategy.
Right. So that is one thing that males and females seem to differ. So we're pretty much the same, males and females, in preferences when we choose a mate. But there are some things that differ, that males are more interested in physical attractiveness, and also that the female has the attributes of being more fertile.
Yes.
Yeah.
And of course, this is not what men think when they look at the woman.
No, no, exactly.
They just see a woman who is more or less attractive. But why the woman is attractive, that is not something that men have direct kind of access to, in a sense. Exactly. That they don't necessarily even understand what makes a woman attractive. And
this is I think it's a great example of what evolutionary psychology is and what it explains. So the why questions. So just like you said, if a male or a female sees a potential mate, it's not that the individual thinks, oh, this individual has a lot of money, and this individual has has these things because it's fertile. I mean, it's or the long. It's not because of that. It's what you experience in the now is something much different.
Yeah, and that is the difference between these kind of proximate level versus ultimate level explanations. So what we find as attractive on the ultimate level, they are basically signals of features that paying attention to and mating with these individuals increase the reproductive success of our ancestors.
Yeah.
And one thing that both sexes find very attractive in a prospective long-term mate is health. So having an immune system that produces a healthy individual. And one thing that this health is detectable from is facial symmetry.
Yeah.
So facial symmetry reflects developmental stability and a good immune system that has been able to fight off different types of pathogens and parasites. And for both sexes, these health cues, for example, facial symmetry, the color or tone of the skin, and so on, are considered attractive because symmetry reflects kind of a good immune system.
Right. So there's a lot of why. there's a lot of why answers to a lot of these different things. Like, for example, the immune system. So you look at somebody, you see a face, you like the face, but you don't. It's not that you think, this person probably has a good immune system.
No, exactly.
Yeah. That would be quite interesting if you were always aware of this ultimate explanation. You were walking around, I'm interested in this food. That is because it helps my ancestors survive. Oh, there's a potential mate. This is because of these factors.
Yeah. I have sex because I want to secure my reproductive success, not because I like it.
Exactly. Yeah,
and that's not the way our brains work. So we are completely unaware of these ultimate explanations most of the time.
Exactly, and that is also, I mean, quite interesting. Also, that it seems like we're guided towards behaviors and towards food. I mean, we're guided. I mean, sex feels great and good. I mean, high caloric food tastes great, and I mean, it's all of these taking your car and driving for 10 minutes can feel great compared to perhaps walking around in the rain.
Yeah. So basically what natural selection has given us are emotions and motivations that guide our behavior towards directions that were beneficial for our ancestors in terms of reproductive success.
Yeah. And this, the mind of us and all these behaviors, it's not like it's been developed just the last couple of 1,000 years or 10,000 years. This is a process that's been going on for a long time, right?
Exactly. I mean, our species, modern humans, we are a very young species. We are only maybe 250, 300,000 years old. But there have been many, many other human species existing simultaneously and long before us. And in the end, humans are just kind of like one branch in the evolution of primates.
Yeah.
So many of the adaptations that we have probably shared with other human species and our ancestors, but we also share with many currently living primate species, especially our closest genetic relatives like the chimpanzees and gorillas. So it's not like our characteristics have evolved in our species, but they are rather the result of an extremely long chain of evolution.
Exactly, and it even goes even further back, right? I mean, at some point we needed some organism needed like a very primal example of eyes or something else, and then that was okay, so eyes are pretty good, and then almost all different species have some sort of eyes, and then it's like maybe it would be good to hear as well, and then we have got some kind of ears that also been, and that was good. So then that also got into, I mean, a lot of different species. And then, so all these, so I mean, we share all these very basic or they're not basic, but we shared all these functions with a lot of species, and all these things that seems to be good has gotten to the next generation of species, kind of.
But you have to keep in mind that natural selection is blind.
Yeah.
It is blind in a sense that it doesn't have a goal or purpose. It works with the material that is there in nature, and by weeding out individuals who have characteristics which are harmful for survival and reproduction, those characteristics disappear from the populations, and characteristics that are beneficial are maintained and then spread in successive generations. But you are right about if we look at life on this planet, it pretty much uses the same design from single-celled organism to complex multicellular organisms, which is the best possible evidence that we have that we actually all current life forms share a last universal common ancestor. What this life form was like, we don't really know, but life got started on this planet something like 3.8 billion years ago, and all current life descends from those first life forms.
And then it's been developed or changed, not developed, but changed ever since.
Exactly. There has been this huge adaptive radiation into different forms of life.
Yeah, maybe we can go back to talking a little bit more about like the primates and how we are similar to them and what we have in common, and also how we're different.
Yeah, one method of doing research in evolutionary psychology is to do comparative research.
Right.
So, for example, compare the characteristics of humans to those of our closest genetic relatives, like chimpanzees and bonobos and gorillas and orangutans, and look for similarities and differences. But when doing so, we have to keep in mind that humans shared a common ancestor with chimpanzees around maybe 6-7 million years ago, and with gorillas around 9 million years ago. And this means that millions of years of evolution, millions of years of change have taken our species to different directions. And the selection pressures that have operated on chimpanzees are different from the selection pressures, are partially different from the selection pressures that have operated on humans. Because if we would have had identical selection pressures, our two species might have never diverged. So when we do comparative research, we have to keep in mind that there's millions of years of evolution between the species. But still doing comparative stuff is interesting because these other apes, they have, for example, different social structures in their groups. And we can kind of compare the social structure in human groups versus chimpanzee groups versus gorilla groups and see what kinds of factors might be beneficial for reproductive success in different social hierarchies. But yeah, doing comparative research, it's not straightforward because we are different species.
Exactly. So they are not the same and we're not the same as that last common ancestor.
But for example, if we look at chimpanzee facial expressions in different situations, we think that we can identify or interpret the same basic emotions that humans have. That chimpanzees seem to have separate facial expressions for different kinds of emotional states, and at least those expressions are highly similar to what we observe in humans who are displaying certain emotional states. So even we cannot ask chimpanzees about the emotions. What is it that they are actually experiencing when they are having a certain facial expression? We infer that their emotional states might be similar to the emotional states of humans.
Exactly. When they look angry and when we look angry,
we look similar.
It's quite likely that they are experiencing something like it is for a human to be angry.
Yes.
Yeah, exactly. And also about because that is also one way of doing research, right, in evolutionary psychology to see if let's say anger, then for example, if anger or is something that has been shown in a lot of different species, then that is something that then we might believe that is something that has been adaptive, right? If we see it in a lot of different species.
Yeah, and if we can somehow prove that being able to act out your anger, for example, in the form of aggressive behavior in certain situations, is beneficial for reproductive success, we could say that anger has been selected for.
Exactly. That is something that has been good before for a lot of different species in a way to help them to survive or reproduce.
Mm-hmm.
But another way of doing research also when it comes to contemporary humans is to see if something exists in a lot of different cultures.
Yes, because the basic idea is that we have inherited our adaptations from our ancestors. We descend from a relatively small group of ancestors. All currently living humans descend from a relatively small number of ancestral humans. And this would mean that we should share the same adaptations, independent of culture.
Yeah.
And for example, when it comes to, if we take emotions as an example, it seems that humans all around the world have the same types of emotions. However, what makes these cross-cultural studies slightly challenging is that culture also modifies how the adaptations are manifested.
Yeah.
For example, we have different types of social norms and rules in different cultures that might affect how we express our emotions. Like in Asian cultures, it is considered impolite to express negative emotions in public to individuals that are strangers to you. So we Westerners seem to have this weird kind of bias of thinking that Asian people are always nice and friendly because they smile all the time.
Yeah.
But at home, these people display exactly the same range of emotions as Westerners do, but in public, the social norm is not to display negative emotions.
Yeah.
So doing cross-cultural studies is a little bit challenging in the sense that you always have to take into account the effect of culture.
Exactly. And that is also, I think, is such a fascinating thing that it seems like we have some kind of evolutionary blueprint in a way, like a starter package. But then as we get into the world, all of us, we have different societies, we are born in different families. So we also, I mean, this is also have a big influence in who we become and in our behaviors.
Yeah, and that is actually highly adaptive, that you are born with a certain type of a blueprint.
Yeah.
That gives you preferences and tendencies and likes and dislikes and ways of reacting to the environment. But that to become adapted to your own environment in the best possible way, it means that your brain has to be malleable.
Yeah, exactly.
From the very beginning, to produce kind of like the best possible fit between your own environment and the individual.
Exactly. And that is also what we see in the brain. I mean, when we are a lot younger, we have a lot of brain cells, and they then get pruned off during our development, right?
Yes. Yeah.
which is, I mean, I think just that is just fascinating, and also probably one of the things, or at least what I believe is one of the things that has really helped us, because we as human beings, we seem to be so good at living in different environments. We can just look at former human beings that we have been living in Antarctica, where it's very, very cold, and also on these very, very hot savannas and a lot of different places in the world. And that seems to be one of the important things for us, that we have been able to adapt to, I mean, to so many different time periods when there's been different temperatures and different places of Earth. And yeah.
And that might be partially because we have this, nowadays I would say, almost unlimited capacity to modify our own environment. So not only that we would adapt to our own environment, but we modify the environment to adapt to us.
Exactly.
And this is what most species cannot do.
Exactly.
And at least cannot do it nearly to the same extent as humans can.
Exactly.
Which then poses other problems, but
yeah, exactly. Which then destroys the Earth. But but that is such an interesting thing, that we have this. I mean, it seems like we have this, and even before we are born, we are affected by how our mothers. And I mean, our mother's life as well. I mean, if our mother are very stressed, that might affect us when we're developing inside the stomach as well.
Yes, and in fact, we have a mechanism for that, which is called these epigenetic changes. So we have the DNA that we have, and that is set for life from the moment of fertilization. But what is important for DNA is, and gene expression, is how gene expression is regulated. And there are mechanisms on top of our DNA, on top of our genes, that regulate gene expression. And these kind of mechanisms are active throughout our life, and they are susceptible to our life experiences, to the environments that we are exposed to, let's say high levels of stress hormones already in the womb, or to environmental toxins or whatever. And some of these epigenetic changes can actually be heritable.
Yeah.
So that the experiences of the mother's, what she has gone through, can be transmitted to the epigenetic mechanisms of the child.
Exactly. Do you have an example of a study where that has been shown, or?
Yeah, that there have been studies on how famine affects the next generation. So, for example, from church records, where it has been possible to track who has married whom and who has had children with whom and how many children they have had and how long the children have lived from generation to generation, we have been able to kind of observe what happened, for example, to the children whose mothers were expecting them during great famines when there was very little nutrition. And these children were born smaller, but they basically didn't have any health problems unless they were exposed to high-calorie diets. As if, though, when the mother was pregnant during famine, when there was very little food available, these babies got tuned to expect to be born into an environment with restricted and limited resources. And they were perfectly healthy as long as they had a kind of like a limited calorie intake. But when these children were exposed to abundance of food, they were actually much more prone to get obese, to get metabolic syndromes and cardiovascular diseases. So they were like, their bodies could not easily adapt to an environment with an abundance of calories.
Exactly, and that is such a good example. We probably lived in the environment that we got born into, but today our environment seems to be able to shift faster than it has been before.
Yeah, so our brains have a lot of difficulties keeping up with the changes in our society. I mean, if we think that first there was 2 to 3 million years of stone tools, no technological advancement, then at some point, proliferation of tools, hunting and gathering tools, we started farming and agriculture and cultivated domestic animals, started to build villages, then cities, empires. Technological advancement since the Industrial Revolution 300 years ago has been immense.
Yeah.
So we basically gone from stone tools to cell phones and space travel in just a few thousand years.
Yeah.
And this technological advancement might be a sign that humans might be a species where our cognition is not heavily limited or restricted by our genetic makeup.
What do you mean about that? Could you explain that?
I mean that this unforeseen technological development means that I'm not saying that our cognition isn't limited. It is limited, but it is so much less limited than, for example, the cognition of chimpanzees.
Yeah.
That there seem currently to be very few boundaries.
Yeah.
But where does this kind of cognitive capacity originate from? Why do we have big brains in the first place? Might not be because it was designed to build cell phones and internet and spaceships.
Why do you think we had big brains in the first place?
Oh, that is a very good question, and it is. There are different theories on why do we have big brains, but one which I think is highly plausible and intriguing explanation is that those species that have very intricate social structures in their groups, social hierarchies, like dolphins and elephants and humans and many other primates, also tend to have very developed neocortex and prefrontal cortex. So it might be that the intricacies of social life have required a lot of processing space. And individuals who are capable of functioning in their own group in a way that they are capable of making friends and allies, and getting help from other individuals, have good support networks, might have better access to resources, they might have been considered as better mate candidates. So our success in the social group might be linked to our reproductive success.
Yeah.
And to be able to play this highly complex social chess that humans play with each other might require a lot of processing space and might explain why our prefrontal cortexes are so big, as well as the cortexes of elephants and dolphins.
Yeah, so it's exactly. So it's this to be so socially successful that has had quite a big demand on the brain. That is something that is quite complex. That is probably needed us to have bigger brains.
Yes, that is one hypothesis. It's called the social brain hypothesis.
Yeah. Which seems quite, I mean, if you just think about, or if I think about my own life, the social interactions with other people really, I mean, when you are talking with other people, you're really in kind of a flow state. It takes up a lot of resources, especially if there's a lot of people in the same room, if you're in a party, for example, or somewhere else. I mean, there's a lot of different things that you're focusing on, and there's a lot of a lot of different things happening inside of you. And I mean, it is quite demanding, I think, when you are with a lot of people.
Yeah, and it's not only the social interaction, but when we are surrounded by other people, we are constantly kind of monitoring them.
Yeah.
And thinking about what they might be thinking.
Exactly. Yeah, exactly.
And thinking about what they might be thinking about us.
Yeah, exactly.
And thinking about what they are going to do next. So we are constantly kind of trying to predict what other people are going to do based on their current expressions. For example, facial expressions or gestures, not only to what they are saying.
True.
So we are spending a lot of brain energy on trying to figure out what other people are going to do next and what other people might be thinking about us.
Exactly. I mean, and one thing where this, I think, becomes quite evident is if you look at a soccer game or something else. I mean, it's not just only to kick around the football. It's also, I mean, to know what might my opponents do, what might my teammates do, and to be able to predict
where you should be in the field.
Exactly. Which, that is also something that really creates a lot of demands, I think.
Yeah.
Yeah, that really sounds quite plausible. Is there any other theory as well to why we have big brains?
Well, I think this one is probably currently the most plausible one.
Right. Another very interesting question, I think, would be just why do you think that we became so successful?
You mean our species compared to... Yeah. Well, first define what is successful. We are successful in a sense that we have really managed to get offspring.
Yeah. Yeah.
in just, I mean, if you think that the world population remained on a very steady level, maybe around 1 billion or 1 million for thousands and thousands and thousands of years. But with industrial revolution, our numbers have increased from 1 billion to almost 7 billion in just a few hundred years. So reproductively speaking, we are a very successful species.
Yeah.
And what then might facilitate this reproductive success is, well, I think one thing is our ability to modify our environments and to harvest resources from highly different types of environments. And also to be able to collaborate so that we can transport goods over long distances and exchange kind of materials that are abundant in one place of the planet and transport those goods to the other side of the planet where such materials or products may not be available at all. So in a sense of having this kind of a network of collaboration on an international level is what might have made our species highly successful in being able to colonize and thrive on different areas of the planet.
Yeah. And also to be able to retrieve all these resources and to be able to collaborate. That also
we need cognition.
Exactly. Then we really need, to have an advanced brain, and that just seems to be. We just seem to be. To be able to come up with new ideas and to be able to find. To make a needle, to be able to make your clothes, or to make a better spear. To have some kind of biological blueprint of being able to come up with new ideas, kind of.
Yeah, and there is some debate over when this kind of let's call it cognitive revolution might have occurred in human evolutionary history.
Yeah.
Because we know that around 35,000, 40,000 years ago, especially in Europe, the records of preserved tools and habitats become much, much richer.
Yeah.
As if though there has been a lot of technological advancement in relatively short period of time. And some have even suggested that this is the period when sophisticated language truly evolved. Not that, language appeared for the first time, but highly sophisticated language came about. And then there has been this discussion whether there might have been some sort of a micromutation in our brain that doesn't leave any fossil records that could have given our species this kind of cognitive capacity to somehow supersede the previous biological constraints. Or is it that at that point in time, human populations kind of reach critical mass and new inventions and new ideas could basically spread from small groups quickly to other groups? So that for this cognitive revolution to take place, there was no need for any type of mutation at all, but rather critical mass of humans. And that is still, I think, an unresolved mystery of when exactly this kind of a huge cognitive capacity emerged. But one suggestion is that it occurred maybe around 40,000 years ago.
Exactly. So is it, yeah, exactly. Is it the gene, or has it been a change in our genes, or has it been that we've become so many that the inventions that we come up with can be communicated to
Yeah. And if we compare human and chimpanzee DNA, they are 98.8% identical.
Yeah.
So there are very few differences between human and chimpanzee genomes. But it's not all about genes. It's a lot about how these genes are being used, how their expression is being regulated. And it is, I would say, conceivable that something might have changed in these regulatory processes 40,000 years ago.
Yeah.
Something that affected maybe our brain structure or the way different brain areas can communicate with each other, and then kind of unleashed or increased our cognitive capacity.
Right. I'm just thinking about the, because it also really has to do, I think, with being able to improve on ourselves. I think that also seems to be a really, really important thing, that we can come up with ideas. For example, I think science is a very, very good example of this. That we have these theories that continues to be improved all the time. That we as humans, we can build on previous knowledge. And that also has to be, I don't know if that comes from the change in our genes or how that came about, but that also seems to be like one of the really, really important thing for our success as a species.
If I could summarize that with one word, I would use the word curiosity.
Yeah.
That this inbuilt tendency to wish to explore, whether it's new areas, new environments, or new ideas, is kind of central to humans, which might have kind of helped us to be reproductively highly successful. Let's put it that way.
Yeah, for sure. Yeah. Is there something else that you think is important to mention when it comes to evolutionary psychology, or that have come up during our discussion?
I mean, I could talk about evolutionary psychology all day long, and I think it has really kind of opened up doors to understanding why our species behaves the way it does. But then the logical next step is that from scientific facts, we cannot directly kind of deduce how things should be.
Yeah.
But if we see something in our own behavior that we don't like, that we think is something that should be changed, can evolutionary psychology help us to change the human species towards a direction that would be kind of more sustainable to our own species and to the planet?
Hmm.
So I think that is a good question, that now that we understand why human groups collaborate with each other, but also constantly compete with each other.
Yeah.
Why human groups and individuals want to kind of have cozy lifestyle and a lot of resources on the expense of what other humans can have or what the planet can sustain. Can we use this information somehow to become better as a species, whatever that better then might mean?
Exactly. How can we use the knowledge that we've gathered about us as human beings to be able to have sustainable lives and
Yes.
to have better lives, or more equally around the globe?
Yes.
Yeah. So what do you think? Is that possible?
It seems that for human groups to be, especially groups that have been hostile to each other in the past or are hostile to each other, for human groups to be able to collaborate, what they need is a common enemy.
Yeah.
And what this common enemy might be, I tend to love the idea that if aliens would attack
Yeah.
the planet, then humans would unite. But there are threats that are kind of much closer at the moment and really threaten our species and other species on the planet, like the climate change and global pollution. And if all humans could see these as a common enemy, then maybe those could be something that would unite mankind, so to say.
Yeah. When I was thinking about climate change as well, that also seems to be, I mean, if you look at the reason why, it also seems logical in a way that a lot of people would focus on themselves and not on this common problem, which of course then also is something that when nobody's focusing on it, then the problem gets worse. So it gets worse for everybody from an evolutionary perspective. Yeah, I mean, that is one of the things, like how can we also go against perhaps the tendencies that we have inbuilt in a way?
Yes, because we have the tendency of being selfish,
yeah,
to a certain degree, to guarantee our own reproductive success,
yeah,
and the best possible circumstances for our own offspring.
Exactly.
And it is difficult to supersede that type of selfishness, of course. But by understanding that if we don't do something about the climate change quite soon,
yeah,
within a few generations, our reproductive success might not be very good,
exactly,
so to say.
Exactly.
That to understand that this problem is not just the problem of people who live in areas where there are floods and tsunamis and terrible hurricanes and drought, that people are not being able to harvest crops anymore. But within a relatively short period of time, this phenomena is going to spread all over the globe and threaten the reproductive success of the whole species.
Exactly. And I think that is a pretty good example of, I mean, understanding why we're focusing on ourselves and not focusing on this problem, and perhaps also then trying to find or using that knowledge to also find a solution of how we could make ourselves focus on the problem together so that we can work on changing it. And then there you talked about like having a a common problem. Because I remember one of these studies also when we were taking the psychology course, that if you could, just like you said, that if you can find a common goal or a common threat, then that is something that can unite, that can unite us.
Yes.
Well, I think that it's been really, really fascinating talking to you. This is one of my favorite subjects, and I think it's such a treat to be able to talk to somebody who knows a lot about it. So I would just like to say a big thank you for taking part and taking your time to come on to the show.
Oh, you are most welcome. We got sidetracked a bit into kind of a big questions that science doesn't have any answers to, but I think it's I think it was a very nice discussion.
Hey friend, hope you enjoyed the episode. I really need your help. I'm trying to get my podcast out there, so I was wondering if you could help me by leaving a positive rating and a review on your Apple device or the podcast player that you're using. That really helps getting the show more visible on iTunes and other players. And if you don't know how it's done, then YouTube has great videos, so you can search there. All right, that's it. Take care.